Welcome to our further discussion on functions. Now we're going to look at analytic representations, i.e. some equations. So the next example we're going to take a look at is called an amortized loan, meaning that your monthly payments are fixed. Credit cards do not have fixed monthly payments, but car loans and home loans and student loans and personal loans, those types of things do. So really, credit cards are kind of the only things that don't have fixed monthly payments because credit cards, in essence, are supposed to be something that are paid off every month. You're really only borrowing the money for 30 days, so to speak. Whereas these other types of loans are long-term loans, like a mortgage can be 30 years, and a car loan is usually about 5 years, and a student loan is usually 30 years or more. I mean, you can set them up for a long period depending on the amount of money. All of these types of loans, and remember from here on out, we'll just be ignoring credit cards. Those really aren't loans. So all of these loans have your principal, the amount that you originally borrow, and that's usually designated by a capital P. They have the APR, which is the annual percentage rate. They have the number of periods, and that's it says here months in 1 year, and that's bad. I don't want you to think of that. The number of periods is just the number of compounds in a year. Yeah, now, yes, most loans, like 99% of them, are compounded monthly. If you have a car loan or a home loan or a personal loan or a mortgage, any of those types of things, you're going to be making monthly payments. So N will, in fact, right, N here, little n means number of compounds in 1 year. N will almost always be 12. But I don't want you thinking that that is set in stone, because you could have a loan that was paid back weekly, and then all of a sudden N would be 52, or it could be paid back quarterly, and then all of a sudden N would be 4, because there's 4 quarters in a year. So N is just number of compounds, number of basically payments in a year, and it is almost always 12. Okay, the term T, that's the time, that's how long this loan is for, and it's always in years. So sometimes in these formulas, instead of T, they use a Y for years, because even if you borrow something for 6 months, your term is going to be based on years, and your T is not going to be 6 for 6 months. It's going to be 0.5 for half of a year. Okay? Now, with all of those things defined, we can see that this function, i.e. this equation, represents the payment you will make on any of these types of amortized loans. So PMT is your monthly payment. There's your APR, that's your interest rate, always written as a decimal. So 12% would be 0.12, 7% would be 0.07. N is your number of compounds per year. For most cases, it's 12. P is your starting principal. That's how much you borrowed in the beginning. And T is the length of the loan in years. Now, the big thing here is you have to make sure you do order of operations correctly, or you're going to get the wrong answer when you're trying to calculate these things with a calculator, or if you're doing it with paper and pencil. Because there's a lot of stuff going on here. There's all sorts of parentheses. There's all sorts of different operations, right? You've got multiplication, you've got division, you've got addition, subtraction, you've got things raised to a power, all of those things, and you have to make sure that you do them in order, or you get different answers. For instance, if you look at a very simple example, like 3 times 5 minus 2, and we know that depending on how you do this, you could get different answers. Now, order of operations tells us first we do things inside the parentheses, and then once you're inside the parentheses, you start over again and you look for more parentheses. And if there are more, you go inside those. And if there are more, you go inside those. You keep going until you've exhausted number one. Once that's done, you see, okay, are there any things that need to be raised to powers inside this parenthesis? No? Okay. Then we're going to multiply and divide everything from left to right. Then we're going to add and subtract everything from left to right. And then we move out of the parentheses and go to the next set and do all that and so on and so forth. So if you're looking at this whole junk here, you'd start inside this set of parentheses because it's the most nested set, right? We've got an outer set here, and then inside those parentheses, we go back inside the parentheses. And then inside here, we would do the division first. We would do APR divided by N, figure out what that is. Then we would do 1 plus that. We would get that number. We'd be done with everything inside these parentheses, so then we would raise it to this power here. Then whatever that was, we would subtract that from 1, and then we'd be done with all of these parentheses. And now we would see we have something divided by something. So all we have is multiplication division. So we would do this times this divided by this, then take all of that and divide it by whatever this final number was we had down there. So you can see there's a lot of steps. And if you don't do them in order, you're going to get the wrong answer. We all know that 3 times 5 minus 2 should be 13, because 3 times 5 is 15, 15 minus 2 is 13. But if you do it in the wrong order, if you first did 5 minus 2 and got 3, then you do 3 times 3 and you get 9, which is wrong, right? You could also do this one wrong. We should know that according to the order, we should do 2 times 3 is 6 first, 6 plus 5 is 11. But if instead you did 5 plus 2 and got 7, and then 7 times 3 was 21, you'd get the wrong answer. So again, order of operations, really important. This fancy formula over here can be written this way. This is kind of how you would type it into a graphing calculator. So these are just two ways of representing the same thing. Okay, let's look at a simple example. You buy a new car for $17,000 and change. You put a pretty good sized down payment on it so that all you have left is 15 grand. So that's going to be your loan amount. That's your principal. They give you a loan for 5 years at 6%, which is pretty crappy because nowadays car loans are like 0.5% to 1% usually. But anyhow, 6%, 5 years. You're going to make monthly payments, right? It says it right here. So you know your number of periods, right, in 1 year is 12. Your term is 5. And if we plug all that information into this formula, it will tell us how much our monthly payment is. So here's a simple way to calculate that payment. We set up Excel with our principal, our APR, our number of compounds, 12, right? Our length of the loan, 5. And now we can take this function and type it in to Excel using the cells instead of just numbers. Right, so we're going to define our payment to be A2 times B2 divided by C2, because we need payment, right, times APR divided by N, so times B2 divided by C2, APR divided by N. And then we put parentheses around that whole thing because that's everything that's on top, and then it's going to be divided by everything that's on the bottom. And on the bottom, right, is 1 minus, and then this stuff inside parentheses. So 1 minus, then 1 plus, and then here we go, APR over N, B2 over C2. And then this 1 plus piece, you can see there's parentheses around the 1 plus piece, and then that little caret means raise it to a power, and then parentheses to tell it what that power is going to be, and it's going to be negative NT, so negative C2 times D2. Close that parentheses. This parenthesis here is closing off this one there so that we get the whole thing, right? So this is divided by that whole thing. And it defines our thing properly. As you can see, I get the same thing when I do it here. And you can see the stuff up here. If I click up there, you can see the colors. And it's kind of hard to see because the colors are kind of similar, but this parenthesis, right, is matched up with that one. Well, actually, this one is matched up with that one. This one on the outside is matched up with that one on the outside. That one's matched up with that one, and so on and so forth. So now we can see that our monthly payment is $289.99, or basically $290 a month. If you actually want to know how much you end up paying, if you do equals this times this times that, right? Because don't we do 12 times 5? That's how many total payments we make. You can see that we pay back a lot more than the $15,000 we owed because of interest, right? In fact, if we do equals this minus this, we can see that we pay almost $2,400 in interest based on this. And the nice thing about having everything dynamic, if we now go, hey, what if they only offer me 1% interest? Look at everything changes. And now we only pay $384 extra. Or how about 0.005, 0.5% of interest? I know that says 1, but that's because we need more decimals. So that's the nice thing about typing these things in as formulas, is that we can change the scenario. You know, what if we want to have a car loan for 10 years? Right, our payment goes down, but the amount of money we owe goes up. What if we buy a cheaper car and it's only 10,000, and so on and so forth? Okay, so that's everything we need to know for 1.2.